All right, let's get right into it. We're all pushing for this big electric future, right? But there's this one huge problem hiding inside the very batteries that are supposed to power everything. And that problem is fire. So today, we're going to look at a brand new technology that isn't just a small step up, it's a total game changer. A battery that by its very nature just can't catch fire. And yeah, no kidding. We've all seen those videos, those headlines, a sleek, futuristic car just suddenly bursting into flames that are almost impossible to extinguish. This isn't just some freak accident. It's a fundamental risk that's literally built into the chemistry of the batteries we depend on. The bad guy in this whole story has a name, thermal runaway, and it is a nasty, violent chain reaction. All it takes is one tiny little flaw inside a battery cell, and in a split second, the whole thing just starts cooking itself from the inside out. It skyrockets in temperature, spewing out toxic gas and those uncontrollable flames. This is the reason lithium-ion fires are so incredibly dangerous. But what if you could just design that risk right out of the equation from the start? Well, that's where our hero comes into the picture. Let's talk about the safety-first battery, the Aqueous Zinc-Ion Battery, or AZB for short. And the secret to why it's so safe is, well, it's actually amazingly simple. It all comes down to replacing a highly flammable fuel with something you just can't light on fire: water. So here's the absolute key difference. Lithium-ion batteries, they use this flammable organic liquid as their electrolyte. I mean, you can think of it as fuel just waiting for a spark. But these aqueous zinc-ion batteries, they use a water-based electrolyte. And, you can't set water on fire. It's that one simple change in the core chemistry that just completely erases the risk of thermal runaway. Gone. And this number, wow, this tells you everything you need to know about the stakes. 700 degrees Celsius. That is hotter than your average house fire. That's the kind of insane temperature a lithium-ion battery can hit when it goes into thermal runaway. An aqueous zinc battery, on the other hand, it just can't get there. Instead of a fiery explosion, it would just, stop working.
Okay, so they're fundamentally safer. That right there is a massive win. But the advantages don't actually stop there. The story gets even better when you start looking at the money and the ethics behind the materials themselves.
I mean, just look at that difference in cost. It's huge. We're talking less than $40 per kilowatt hour for zinc compared to $100 or more for lithium-ion. And you might be asking why. Well, it's because zinc is one of the most common, most used metals on the entire planet. This isn't some rare, exotic material. It's everywhere. And that abundance leads to this really important ethical advantage. You see, a lot of high-performance lithium batteries depend on cobalt, and that material is often tied to some pretty awful mining practices, so much so that people call it blood cobalt. Aqueous zinc batteries, they don't need it. They use more common stuff like manganese, which means we can build a truly green energy future without that hidden human toll. So beyond being safe and cheap, zinc is just a fantastic material for this job. It can actually pack more energy into the same amount of space than lithium. Plus, it's totally stable in regular air, which is a huge deal because it slashes manufacturing costs. You don't need these super expensive, super dry rooms to build them. And because it's mined all over the world, we don't have to worry about the same kind of supply chain chaos that we see with lithium. Okay, so this all sounds a little too good to be true, right? You've got to be wondering, if they're so great, why aren't these zinc batteries in everything we own already? Well, for the last few years, there's been this quiet race happening in science labs all over the world to solve a few final tricky chemistry problems. So scientists have basically been fighting three main chemical enemies. First up, these things called dendrites. They're these tiny, needle-like bits of zinc that can grow and cause a short circuit. But clever new 3D anode designs are putting a stop to that. The second enemy is hydrogen gas. Sometimes the water in the electrolyte can split and create gas, which makes the battery swell up. The fix for this is really smart. They use these super concentrated water and salt electrolytes that basically lock up all the water molecules so they can't split. And finally, they're working to make sure the cathode doesn't slowly dissolve over many, many cycles. These aren't deal breakers, you see. They're just the last few pieces of the engineering puzzle, and scientists are clicking them into place as we speak. So with these big hurdles finally being cleared, the path to the market is really starting to open up. The big question now is, where are we going to see this amazing technology show up first? And the answer might not be what you think. The first and most obvious place for these is grid-scale storage. I'm talking about huge battery barns that store of solar and wind power for when we need it. In that situation, safety is absolutely priority number one, and a little extra weight just doesn't matter. But the ultimate goal, that's electric vehicles. And while zinc batteries are a little heavier right now, here's the thing, they don't need all the heavy, complicated cooling and fire suppression gear that lithium-ion packs do. So when you look at the whole system, they could soon be just as light. And the benefits just keep coming, even after the battery's life is over. Zinc batteries are way simpler and cheaper to recycle. Their carbon footprint, from the mine all the way to the factory, is lower. And with no toxic solvents inside, they're a whole lot better for the environment. So this isn't just a safer battery, it's a truly more sustainable one, from beginning to end. Which brings us to this really important question we all have to start asking ourselves as we build out this new energy world. For decades, the goal was always about cramming in more energy, more range, no matter what. But now, we actually have a choice. Is getting the absolute maximum range really worth that small but terrifying risk of a fire? More and more, it seems like everyone from car makers to customers is starting to say, probably not. What this all shows us is that the next big leap in battery tech, it's not just about squeezing a few more miles out of a charge. It's about building on an entirely new foundation. One based on safety, on affordability, and on a real sustainability. That quiet race is just about over, and it looks like a water-based solution is about to take the lead.